So this is my average rate of change calculator spreadsheet, and you're going to be estimating instantaneous rates of change to parabolas, and you're going to be using your average rate of change tool. So this one is set up for doing a parabola just y equals x squared. So you maybe can't see that formula, but it says a5 squared, which is taking my x coordinate and squaring it. And this one is taking x plus a and squaring it. And everything, all these calculations are being done to calculate what the average rate of change or the slope of the secant is. If I want to get to an instantaneous rate of change at the x-coordinate 3 on that parabola, what I'm doing is I'm shrinking a down. So graphically, if you were to look at it graphically and visualize it that way, so graphically what we're doing is we're bringing the 2 points closer and closer together by shrinking our a value, and we're going to be getting closer and closer to an instantaneous rate of change when x equals 3. So we're calculating what is pretty much the tangent slope. So on my calculator, my spreadsheet calculator, when x equals 3, I'm going to be changing my a value to, say, 0.5, and I'm going to have a look at what happens to my slope here. And then I can change my a value down a little bit more. I can go down to 0.1 and see what happens to my slope here. Now it's 6.1, and if I go to 0.01, I can see it's just probably going to be around 6. That's going to be the slope of my tangent calculator. Anyways, go through that systematically for each parabola, and I'm recommending you start with x values at -3, find out what the instantaneous rate of change is, or at least estimate what the instantaneous rate of change is, and then go up to a value of 3.